Okay, so now that we've gone ahead and kind of learned equations of lines, learned how to check the points on those lines, we're going to do one last thing with these equations of lines. And what we're going to do is check when two lines intersect when they belong in three space. And this problem is going to be the first of your two participation problems for Thursday. So go ahead and take careful notes here of the steps to follow because you'll follow very similar ones to answer that problem. And the two lines we're going to think about are going to be x minus 1 equal to 2t, y plus 1 equal to 1, z minus 2 equal to 4. Oops, forgot my t's there. And x plus 2 equal to 4t, y equal to minus 3t alone, and z minus a half equal to minus t. So that's two equations for lines. And real quick, just recapping what we learned so far, we can read these equations and see that this line goes through the point 1, minus 1, 2, and it heads in direction 2, 1, 4. This line goes through point minus 2, 0, a half, and heads in direction 4, minus 3, minus 1. You should get really used to doing that real quick read off of these equations. The reason I wrote these two directions down is because looking at this tells us that these two lines should intersect. The same way that you know that two lines with the same slope are parallel and will never intersect, if two lines are headed in the same direction, they're parallel and so they'll never intersect. Because these are different, we know that these two lines should intersect with each other. You don't actually have to do that check. It would pop out of the math anyhow that they don't intersect later, but it's kind of a good, before we waste a lot of time, you could answer the question that they don't intersect if that was the case. To check if they do intersect, I need to find the same x, y, z for both lines. If they both pass through the same point x, y, z, if I could plug that number in and verify that it's on the line, then I would know that both of them intersect and it happens at that point. So for my first line, x is equal to 2t plus 1, y is equal to t minus 1, and z is equal to 4t plus 2. Just solving for x, y, and z. And for the second line, I get x is equal to 4t minus 2, y is equal to minus 3t. I have no idea what that dead zone is right there. And z is equal to minus t plus 1 half. And I want to have a t that I plug in here, gives me x, y, z, that matches the x, y, z right here. But the only difference is it doesn't have to happen at the same t. All that matters to me is that they eventually pass through the same point. So temporarily, I'm just going to use a different letter for this parameter here. I'm going to say, okay, doesn't matter when it happens, but at some parameter value s, I hit x, y, z, and it has to match the x, y, z I happen to hit at some parameter value t. And I'm going to find that particular point by finding the t and s that make these x, y, z's equal. My goal here is to solve for s and t, then that'll tell me the x, y, z where it happens. It's a little like circular. But for my x value, I have 2t plus 1 should be equal to 4s minus 2. That's going to tell me something for sure. And for y, I'm going to have t minus 1 should be equal to minus 3s. So this one will tell me that t should be equal to 1 minus 3s. This one tells me that t should be equal to 4s minus 2 minus 1 minus 3 over 2. So I have two equations, two unknowns. I kind of have to put them together in order to solve for anything. And I'll do that on the next page. 4s minus 3 over 2, 1 minus 3s. All right. Now I have two equations. I can set them equal to each other to try and solve for anything. So that's going to give me 4s minus 3 is equal to 2 minus 6s, or 10s is equal to 5. Tells me that s is equal to 1/2. And then kind of going back to t is equal to 1 minus 3s, it's equal to 1 minus 3/2 is minus 1/2. So there's my s and t. Actually, yeah, I'm going to have to copy all these over. 2t plus 1, t minus 1, 4t plus 2. So yours is easier. It's all in order. You don't have to recopy this stuff. 4s minus 2 minus 3s minus s plus 1/2. I really wonder what's happening there. Okay. 4t plus 2t minus 1. Yeah, I got those. Okay, so when I plug in my s equals 1/2, I'm going to get 4 times 1/2 minus 2. That's just going to give me 0. Minus 3 times 1/2 gives me minus 3/2. And minus, oops. Oh no, I just wanted the undo button. Minus 1/2 plus 1/2 will give me 0 again. So s equals to 1/2 gives me the point 0 minus 3/2, 0. Here, when I plug in t equals minus 1/2, I'll get 2 times minus 1/2 plus 1 is minus 1 plus 1, 0. Minus 1/2 minus 1 is minus 3/2. And 4 times minus 1/2 plus 2 is minus 2 plus 2 is 0. So that's the point 0 minus 3/2, 0. And they're the same thing. So that's great. All my math worked out, and I can now say they intersect at 0 minus 3/2, 0. That's my answer to the question, where do those two lines intersect? And this section has been kind of a grab bag of facts about lines. Don't worry, we're just still building the foundation for working in 3-space we're going to use throughout the rest of the semester.